Problem based on eigenvalues and eigenvectors. Problem number 1. Find the eigenvalue and eigenvector of the matrix A equal to 1, 0, minus 1, 1, 2, 1, 2, 2, 3. So solution, step number 1. Step number 1, to find characteristic equation. We know that characteristic equation for 3 by 3 matrices, lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0, where s1 is sum of the main diagonal elements. Here diagonal elements are 1, 2 and 3. So sum of the main diagonal elements 1 plus 2 plus 3, which is equal to 2 plus 1, 3, 3 plus 3, 6. S2 is sum of the minor of the main diagonal elements. Here diagonal elements 1, 2, 3. Minor of 1 is it minor of 1? Omit that column and rows. So we get 2, 1, 2, 3. And then minor of 2. So omit that row and omit that column. We get 1 minus 1, 2, 3. Then minor of 3. So omit that column and omit that row. We get 1, 0, 1, 2. So how much? Determinant expansion 2 into 3 6 minus 2 into 1 2 plus 1 into 3 3 minus 2 into minus 1 minus 2, so minus into minus plus 2, and then 1 into 2 2 minus 1 into 0 0. So 6 minus 2 4, 3 plus 2 5 plus 2, so 9 plus 2 is 11. S3 is determinant of A. So what is the determinant? 1, 0, minus 1, 1, 2, 1, 2, 2, 3. So determinant expansion. So first 1. So omit the column and rows. We get 2 into 3 6. Minus 2 into 1 2. Then A to 2 element, minus of A to 2, there is 0, into omit that row and omit that column. We get 1 into 3 3 minus 2 into 1 2 minus 1 A 3 3 minus 1 into how much? Determinant expansion 1 into 2 2 minus 2 into 2 4. So 6 minus 2 4, 0, then how much? 4 minus 2 minus 2. So 4 plus 2, 6. S3 value 6. Substitute the value of S1, S2 and S3 in equation 1. Equation 1 as formula. So substitute the value of S1, S2 and S3 in equation 1. So in equation 1 we get lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0, which is the required characteristic equation for 3 by 3 matrix. That's step number 1, right, to find the characteristic equation. Step number 2, to find eigenvalues. So to solve the characteristic equation, we get the eigenvalues. We know the characteristic equation is lambda cube minus 6 lambda square plus 11 lambda minus 6. So solve the characteristic equation, we get the characteristic roots or eigenvalues. We get the characteristic roots eigenvalues. So characteristic equation in 3 by 3 matrix. So solve by synthetic division. So how to solve synthetic division? So step number 2, solve by synthetic division. By synthetic division. So write down the coefficients of characteristic equation. What is the characteristic equation? Here, right? So what is the coefficient of lambda cube? 1. Lambda square coefficient minus 6. Lambda coefficient lambda 11. Constant is minus 6. So here we want 0, you can always put 1, right? So start by trial and error method, start with plus 1, minus 1, plus 2, minus 2 and so on. Suppose we start with plus 1, what is 1 into 1? 1, minus 6 plus 1 is minus 5, 1 into minus 5 is minus 5, 11 minus 5 is 6, 1 into 6 is 6, so minus 6 plus 6, 0 we get. Similarly, one more time. One more time, again we start with plus 1, minus 1 and so on. Suppose if we start with 1, what is 1 into 1? 1, we get minus 4, 1 into minus 4 is minus 4, not equal to 0. So again start with minus 1, plus 2, minus 2 and so on. Suppose if you put 2, 1 into 2 is 2, minus 5 plus 2 is minus 3, 2 into minus 3 is minus 6, so we get 0. So therefore the roots are, or the eigenvalues are, 1, second root is 2, third root is plus 3. This is lambda coefficient, this is lambda, this is constant, this is lambda coefficient. So lambda minus 3 equal to 0, therefore lambda equal to 3. Therefore the third eigenvalue is plus 3. Here write down non-repeated eigenvalues. Step number 2. So the eigenvalues are 1, 2 and 3. Second step over. Then third step, last step. Step number 3. Define eigenvectors. We know that eigenvector equation is A minus lambda I into x equal to 0. Where A is the given matrix, lambda is the eigenvalue, I is the unit matrix, x is non-zero column vector, right? So substitute the value of the given matrix. What is the given matrix value? Is the given matrix. So equation is A minus lambda I into x equal to 0. A is given matrix, that is 1, 0, minus 1, 1, 2, 1, 2, 2, 3. A minus lambda into I. Minus lambda into I. I is the unit matrix. A given matrix is of the order 3. Therefore, write it in order 3. So, our unit matrix 1, 0, 0, 0, 1, 0, 0, 0, 1 into x. What is x? X is non-zero column vector. So non-zero column vector for 3 by 3 is x1, x2, x3. Right? A is the given matrix, lambda is the eigenvalue, I is the unit matrix, x is the non-zero column vector. So just subtract the two matrices. So first multiply with lambda. So lambda, 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 and then subtract two matrices. We get 1 minus lambda, 0, minus 1, 1, 2 minus lambda, 1, 2, 2, 3 minus lambda, into x1, x2, x3 equal to 0. So let it be equation, let it be equation 2. Right. So we have three different cases. First case is when lambda equal, what are the eigenvalues? 1, 2 and 3. So first case is when lambda equal to 1. So substitute the value of lambda in equation 2. We get 1 minus 1, 0, 0, minus 1, 1, 2 minus 1, 1, 1, 2, 2, 3 minus 1, 2, into x1, x2, x3 equal to 0. So just multiply, right? Multiplication of two matrices, right? 0 into x1, 0 x1. First row, first column, 0 into x1 plus 0, plus 0 into x2, 0 x2, minus x3 equal to 0. Right? And then 1 into x1, x1, 1 into x2, x2, 1 into x3, x3. Third equation is 2 into x1 plus 2 into x2 plus 2 into x3 equal to 0. So give some numbers, right? Let it be equation 1, let it be equation 2, let it be equation 3. So consider any two equations and solve by cross multiplication rule. So let it, which two equations are different? Here all the three equations are different, right? So all the three equations are different. No. Equation 2. So if you divide by 2 in equation 3, we get 1, 1, 1. So equation 2 and 3 are same. So consider any two different equation and solve by cross multiplication rule. So consider equation 1 and 2. Why we consider equation 1 and 2? Equation 2 and 3 are same, right? So consider equation 1 and 2 and solve by cross multiplication rule. Solve by cross multiplication rule. So cross multiplication rule. So start with x2, end with x2. So here we have three variables, x1, x2, x3, right? So start with x2, end with x2. x2, x3, x1, x2. Here we are going to solve equation 1 and 2. So in equation 1, what is the coefficient of x2? 0. Coefficient of x3? Minus 1. Coefficient of x1? 0. Coefficient of x2, 0. Right. In second equation similarly, in equation 2, we have 1, 1, 1. So x1 value is 1 into 0, 0, minus 1 into minus 1, minus 1, so plus 1. x2 value is minus 1 into 1, minus 1, minus 1 into 0, 0. x3 value is 0 into 1, 0, minus 1 into 0, 0. So therefore, x1 value is 1, x2 value minus 1, x3 value 0. So therefore, the first eigenvector x1 value is right on the value of x1, x2, x3. So 1, minus 1, 0. This is the first eigenvector. Similarly, we want to find the second case and third case. What is the case 2? Case 2 is case 2 lambda equal to 2. Case 2 lambda equal to 2. So substitute the value of lambda equal to 2 in equation 2. Put lambda equal to 2, 1 minus 2 minus 1, 0 minus 1, 1, 2 minus 2, 0, 1, 2, 2, 3 minus 2, 1 into x1, x2, x3 equal to 0. So similarly, just multiply first row first column, second row first column, third row first column, we get three equations. So minus x1 plus 0x2 minus x3 equal to 0. Let it be equation 1. Second equation, x1 plus 0x2 plus x3 equal to 0. Third equation, 2x1 plus 2x2 plus x3 equal to 0. So here, first equation throughout multiplied by minus, we get 1, 0, 1. So equation 1 and 2 are same. So consider any two different equations and solve by cross multiplication rule. That is a cross multiplication rule. So solve equation 2 and 3. Solve equation 2 and 3 by cross multiplication rule. CRM. Solve 2 and 3 by cross multiplication rule. What is the coefficients in equation 2 and 3? 0, 1, 0 in equation 2 and 3. 0, 1, 1, 0. In equation 3, 2, 1, 2, 1, 2, 2. 2, 1, 2, 2. Right? 2, 1, 2, 2. So what is the value of x1? 1 into 0, 0, minus 2 into 1, 2. x2 value? 1 into 1, 2, 2, minus 1 into 1, 1. x3 value? 1 into 2, 2, minus 2 into 0, 0. So therefore, minus 2, 1, 2. So first value always should be positive. So throughout multiplied by minus, we get plus, minus, minus. Therefore second eigenvector is 2, minus 1, minus 2. So last case, when lambda equal to 3. So case 3, when lambda equal to 3. Substitute the value of lambda equal to 3 in equation 2. What is 1 minus 3 minus 2, 0 minus 1, 1. 2 minus 3 minus 1, 1. 2, 2, 3 minus 3, 0. So here, so first equation throughout multiplied by minus, we get 2, 0, 1. So all the three are different, right? So all the three equations are different. All the three equations are different. Consider any two and solve by cross multiplication rule. So consider any two. So I am considering equation 2 and 3, right? So consider any two equation and solve by cross multiplication rule. Cross multiplication rule. What is that equations? What is the second and third equation? First equation is minus 2x1 plus 0x2 minus x3 equal to 0. Let it be equation 1. Second equation, x1 minus x2 plus x3 equal to 0. Let it be second equation. Third equation, 2x1 plus 2x2 plus 0x3 equal to 0. 2x1 plus 2x2 plus 0x3. So consider two different equations. I am considering equation 2 and 3 and solve by cross multiplication rule. So consider equation 2 and 3 and solve by cross multiplication rule. So equation 2. What is the coefficient of x2? Minus 1, 1. x1 coefficient? 1. x2 coefficient? Minus 1. Similarly in equation 3, 2, 0, 2, 2. So what is x1 value? So just determine expansion. Minus 1 into 0, 0. Minus 2 into 1, 2. X2 value 1 into 2, 2. Minus 0 into 1, 0. X3 value 1 into 2, 2. Minus 2 into minus 1, minus 2. So plus 2. Right? Right. Minus 1 into 0, 0. Minus 2. 1 into 2, 2. Minus 0. 1 into 2, 2. 2 into minus 2 plus 2. Right. So x1 value minus 2. X2 value 2. X3 value 4. So throughout divided by minus 2, first value always should be positive, right? So throughout divided by minus 2, we get plus 1, minus 1. The next x3 value is, or how much? Minus 2. So therefore x3 is, third eigenvector is 1 minus 1. That's all. So the question is to find the eigenvalues and eigenvectors. So eigenvalues are 1, 2 and 3. Then eigenvectors are x1, x2 and x3.